Good morning, everyone. Myself, Rashekar Reddy. My roll number 23 4G 1A0322. Branch Mechanical. Today, my topic is characterization of sensible and latent heat loads. Subject name Thermodynamics. Subject code 23 MEC 301. Characterization of sensible and latent heat loads. Introduction to heat loads. Heat loads are essential in understanding energy transfer in buildings and HVAC systems. They are primarily classified as sensible and latent heat. This presentation will explore the definitions, characteristics, and implications of both heat loads. How is heat transferred? There are three ways heat transfer can move: condensation, convection, radiation. Definition of sensible heat. Sensible heat is the heat exchanged by a substance that results in a temperature change. It can be measured using a thermometer and is felt as a temperature change. Sensible heat is crucial in maintaining comfortable indoor environments. Sensible versus latent heat. 60 degrees Fahrenheit sensible heat equals to 212 degree Fahrenheit. Second one, 212 Fahrenheit equals to latent heat 212 degree Fahrenheit. Definition of latent heat. Latent heat refers to the heat absorbed or released by a substance during a phase change. This is this heat does not result in a temperature change but is essential for processes like evaporation and condensation. Understanding latent heat is key for managing humidity levels in indoor space. Latent heat, temperature versus heat supplied. Draw the graph. Latent heat of fusion, temperature remains constant as solid turns to liquid. Latent heat of vaporization, temperature remains constant as liquid turns to gas. Measurement of sensible heat loads. Sensible heat loads is typically calculated using temperature differences and heat transfer equation. The formula used is Q equals to M into Cp into delta T, where Q is heat, M is mass flow rate, Cp is specific heat capacity, and delta T is temperature difference. Accurate measurement is virtual for effective HVAC system design and energy management. Q equals to 1.08 CFM delta T. Q equals to MC into delta T. M1 Cp equals to 0.24 CFM air F degree Fahrenheit equals to air. M equals to M naught Cn into delta T plus M naught V Cp1 V into delta T. Measurement of latent heat loads. Latent heat load is calculated based on moisture constant temperature changes in air. The formula Q equals to M into HFG is used, where Q is latent heat load, M is mass flow rate of moisture, and HFG is a latent heat of vaporization. Monitoring latent heat is essential for controlling humidity and ensuring comfort in buildings. Factors affecting sensible heat loads. Various factors influences sensible heat loads including insulation, building orientation, and occupancy. External temperature variations and solar grains also significantly impact sensible heat calculations. Understanding these factors helps in energy efficiency in building design. Interactions between sensible and latent heat. Sensible and latent heats of often interacts affecting overall thermal comfort. A rise in indoor temperature can increase the moisture holding capacity of air, impacting latent heat load. Understanding their interactions is crucial for effective HVAC system performance and energy efficiency. Implications for HVAC design. Proper characterization of heat loads is essential for HVAC system sizing and efficiency. Oversized systems can lead to short cycling, affecting comfort and energy use. Accurate heat load calculations ensure that both sensible and latent heat are addressed in design. Conclusion and future directions. Understanding the characterization of sensible and latent heat is vital for effective climate control. Advancements in technology provide new methods for measuring and managing heat loads. Future researchers should focus us on integrating smart building technologies to optimize energy efficiency. Heat transfer explained. Sensible versus latent heat. Temperature versus heat added. First one, sensible heat. Second one, latent heat of fusion. Third one, sensible heat. Fourth one, latent heat of vaporization. Fifth one, sensible heat. Thank you. This is my PPT CA2 assignment for thermodynamics.